Hi, I'm Frank, and today I'm going to show you how InstrumentStudio empowers you to go from interactive measurements to automated test sequences in seconds. So to do that, I'm going to be testing a USB charging brick, and that's connected on all 4 channels to our SMU. I also have 2 oscilloscopes that are probing those power lines, and what we're going to do is give it some simulated loads, and then also monitor the ripple voltage as those loads change. So let's get started in InstrumentStudio and interact with our DUT. So InstrumentStudio is our companion software for PXI that lets you take interactive measurements and get your instruments configured so that you can take that into your LabVIEW or your test stand sequences. In InstrumentStudio, you can see that I've previously configured an interface here. And the first thing we're going to do is we're going to give that DUT a load. So I have 4 channels here. And I'm just going to click Run, and you can see that each channel has a little bit of variation, but it's around 5 volts. That's what we would expect from USB-A. And then we're also seeing that the currents, while they're all nominally around minus 100 milliamps for the load, are a little bit different as well. Okay, so we've got power, we've got load. Now let's switch to an oscilloscope panel. And in here, I'm going to have all 4 channels looking at the ripple voltage. So we can see that there's a ripple voltage here. I've also got measurements down here to measure cycle RMS. So that's the power that's coming out of this ripple signal. One other thing to mention is that each one of these channels is AC coupled. So that's why you don't see the 5 volt offset that we did on the other panel. All right, so we've looked at that DUT in the steady state, but what happens when we vary the load across all of the different channels? Well, I've also built a panel over here. So this is using the SMU again. This has each channel cycling through different steps. So it's going to have minus 150 milliamps, minus 250, minus 350, going across all 4 channels. All right, so in order to view this panel and the oscilloscope at the same time, I'm going to drag the SMU into its own window, and then I'll have the oscilloscope over here as well. All right, that looks pretty good. Now, let's start running this current sequence. All right, so we're seeing that it looks like the ripple voltage is kind of getting a little bit bigger and a little bit smaller depending on the loads that we're giving it. Now, this is cycling through 0.3 seconds for each one of those power levels, so it's a little bit fast. Now, you could also do some measurements, but really what you want to do here is maybe automate or introduce some signal processing to find out more about this signal. To do that, we're going to go into LabVIEW. All right, so let's take a look at how to do that. The first thing to do is to click the panel's options and go to Export and export your driver configuration. I'm just going to put this on the desktop for now. And then in LabVIEW, what we're going to do is import that file that we just exported from InstrumentStudio, and that has things like the hardware, the channel names, the coupling, for example, the bolts for division, all of that stuff comes along with the file. So this is what that block diagram looks like. And you would just have a file path control on your front panel to pick that configuration file, and then you load all of that and you start reading it in a loop. Very simple. Now in comparison, if you wanted to set up the entire measurements in LabVIEW code, this is kind of what that would look like. So you can see there's some more setup involved, but you get a little bit more control than what you would get from the interactive tool in InstrumentStudio. All right, so we've done LabVIEW. Let's take it one step further and export the configurations from InstrumentStudio to test stand. I'll open up InstrumentStudio again. I'll bring my windows back together. All right, now say I wanted to export this current sequence configuration to test stand. Well, we have a export to test stand button here at the top of the panel. And when I click that and export, it's going to open up test stand. The test stand has a audio configurations window down here at the bottom left. You can see that I have a couple of other configurations as well, but let's take this current sequences one, current sequences multiple. and I might want to drag that into the setup step group in TestStamp. So that gets all of my hardware ready to go for the rest of the test steps that are in the main part of the sequence. All right, so to recap, what we've seen is we interacted with our DUT and explored it in InstrumentStudio. Then we exported that configuration that we wanted into LabVIEW code. And finally, we exported that into TestStamp to reuse as an I/O configuration. And that's how InstrumentStudio lets you go from interactive measurements to automated test sequences. Thanks for joining.